I did a silver spring break. Electrical unit circuits. A circuit is a set of electrical components connected so that they make one or more complete paths. All right, so does a bird on a wire get shocked?
No.
No, why?
Because it's indestructible.
Obviously never hit one with your car. No, he's not getting shocked. He doesn't land there and just like deal with the pain of the electricity going through him. For you to have that moving electricity, for it to move from one area to the next, you have to have a potential difference. Okay? In this case, the bird has two legs with his little feeders wrapped around the wire. So anything that he's experiencing is the same on both of his feet. There's no difference. He does not get shocked because there's no potential difference there.
Let's say we grab it. Who gets shocked?
Yeah, if you grab the bird while it's like both his feet are on the wire.
Kind of depends on how you grab him.
Like the wire.
Don't do that.
I mean, are you standing on the ground when you just grab
No,
it?
I'm not grabbing it.
You're not grounded.
So, I saw, I want to say it was in Russia, a couple of years ago. There was a video of like a bear got scared, ran up a light pole.
What got scared?
A bear.
A bear.
Yeah, like a baby-ish.
I think it's a meow.
And it ran up a light pole?
Like one of the tree-looking ones. The one with the wood, not a light pole, but electricity pole. And he got up there, and then he got stuck.
Wait, can a bear climb the tree?
Bears can climb trees. Yes.
Wait, have you seen that one video? There's a bear that climbs in the tree and they shoot it with a tranquilizer and the bear falls out of the tree and lands on the trampoline?
Yeah.
Video.
Anyway,
It's so funny.
so back to my bear story. The bear got scared, and he thought, as a bear probably normally would, it would be best to cross, just kind of, walk across the wire. He was fine when one of his feet was on that wire. No potential difference across his paw. When his second paw went to a different wire, it made a boom.
Oh, he died.
He did not die. He was electrocuted. He fell.
He didn't die.
He didn't die. There were people under there to catch him with a trampoline. He got treated, I know, for burns on his feet and stuff like that.
There's walking sound.
What would you like? Would you like to go up?
Like, I know that no one's like gonna sit there with a bear and like,
Yeah, I mean,
but,
so
like they just kind of like saw it go up. They're like,
someone called for help. Rescuers came, firefighters came, the whole wildlife rehab people came. They got the trampoline out, that kind of stuff.
What about panda bears? Are they endangered?
oh, they're cute though. Can you get them as pets?
So
No, endangered.
Are they mean?
Oh, is anything ever mean
What do
until
you
we
call
teach
them?
it to be?
Huh?
The lion mean?
The cute ones are mean.
I mean, it can be
Why is it mean?
because
Because it wants to eat and
Yeah.
survive?
Yeah.
That's mean. Because I like to eat and survive.
Oh, so we are mean.
Are they violent?
Pandas, it can hurt you.
Oh, wasn't it
I heard
koalas?
koalas are pretty violent.
Oh, we will talk about koalas in a minute. Let's get back to
Can you
this real
look
quick.
at koala?
Huh?
Can you look at-
Yeah. Don't. I'll tell you why in a minute. Okay. So, parts of a circuit. We have a wire. Wires are super, super technical. They're really hard to understand. They connect everything. Resistors resist those charges. You can see them oftentimes drawn like this on the wire. That would be a resistor. Or you can see them like this or like this. Those are both light bulbs. Okay, I'm sorry. I will work on my light bulbs.
No, the first light bulb looks like the second one looks like an ice cream cone.
Yeah.
No, you lost. Now you're just like Katie.
All right, batteries are going to look something like this. It's not supposed to have a little tail end. It's going to look like that. There's a distance separating them. They'll usually have like a plus and a minus somewhere on them. That would be a battery.
Wait, okay, what's the bottom one supposed to look like? Like just a line?
It's, let me draw it the other way. So one line's usually, oh, you can't see that. One line's a little bit shorter than the other, plus, minus. All right, and then you have a switch. Switches are exactly what they sound like, that you are aware of switches. You use them probably every day. They allow electricity to flow when they're closed. So they allow flow when closed. All right, I told you we'd talk a little bit about light bulbs. So here we are. The most typical type of light bulb that you see is the incandescent. The filament is the resistor. When that filament heats up, it produces light. Most of the energy that goes through a light bulb like this is lost as heat.
Is it like the same for LED light bulbs?
Mm-mm.
The why are they so much
Are
brighter?
these kind of the same?
I have no idea what type of light.
These are the long bar ones.
Yeah, but I don't know what which types they are. If they're just long bar fluorescent, or if they're
Wait, what is it?
They look like it.
the
Most energy is
lost as heat. All right. Then you have the compact fluorescent. Now, if you've ever bought light bulbs, these 2, 3, 4 times as expensive as these. These also last longer though. So it's one of those benefits. So they use less energy and they last longer. It's better in the long run. But I'm gonna be honest, if it's not close to payday, I'm probably just gonna buy the incandescent, right? I mean, you know, if you're short on money, you solve today's problems, not tomorrow's. You don't have to pay the electricity bill. So with a compact fluorescent, the current enters the tube and reacts with gases. That reaction produces UV light. Can you see UV light? No. There are animals out there that can. We are not one of them.
Who can?
Mantis shrimp.
What?
Mantis shrimp.
Big ones?
The mantis shrimp. They're like the coolest shrimp ever.
Oh,
I like
They can shoot water at the speed of a bullet. Like mantis shrimp are cool.
Wait, what about that one that can it's like a lobster or a shrimp that can close its thing and makes a big boom?
Yeah, that's
okay,
a,
so what about the fish with the
that's just an anglerfish. It's like the Nemo fish.
how do they taste like?
Oh, he has. I believe he has fluorescent capabilities. A lot of fish do. They can produce their own light in the deep dark.
Or is it them to get energy from something? So
Yes, and there are different ways that they can do that from bacteria or from their own chemical reactions. Same way like a lightning bug can produce light. Lightning bugs? Oh no, you can't replicate the pressure down there, and so they come up looking all and dead. All right, so these guys produce UV light. You cannot see UV light; that does nothing for you. So the coating takes the UV light and makes it into visible light. So they all have a coating on the inside that takes the UV, changes the frequency of the light, makes it visible. All right, so we know that one battery and one bulb, V equals IR, I equals V over R equals V over I. But what happens if we start adding more bulbs?
Like power.
We're going to talk about power later, but today we're going to talk about series circuit. Series circuit has one way for the charges to flow. If a bulb goes out, everybody goes out. So in a series circuit, if a bulb goes out, everything goes out. Now, if you notice on my notes here, I put a little special thing on I, right? Series, the word series, has an I in it, yes?
Yeah.
Cool. So when you are solving series circuits, you need to remember that I by placing a star on it. Every time you do a series, that I gets a star. Okay. It says a 12-volt battery, a 1 ohm and 2 ohm resistor. So we're going to draw that. It really does not matter where you put your resistors at, as long as everything's in one box. That would be what you need for a series circuit. Yeah, you could have them right next to each other. You can have them both right there. It doesn't really matter as long as they're in one box together. All right, so the first thing we're going to do is fill in what we know. So I have resistor 1, resistor 2 in total. I know that my first resistor I said was 1 ohm, so I'm going to put 1 ohm on my table. My second one, oops, I'm apparently incapable of drawing the right number of boxes. Let's do 1 ohm there, because, yeah, that was my bad. The second one, therefore, would be 2 ohms. And then I need to find my total. So to find my R total, oh, I can put in here that I have a total voltage of 12.2 for volts, because I do. So to find R total, all I have to do is add them up. Okay. Now, if you need to get out your calculator, get out your calculator. That's fine. What is 1 plus 2? 3. So my total resistance for this circuit is 3 ohms.
Wait, so would both be 6 and 6?
No, we're gonna look at it. So don't jump to conclusions. So Now, I have voltage, I have my resistance. I'm going to solve for my I. So step 2, solve for I. Okay. I is going to be voltage over resistance. Again, use your calculator. What is 12 divided by 3? 4. 4 amps. Okay, now remember how I told you to put that star above I. The reason is that in a series circuit, the current is constant. So series has an I, so I is constant. So I gotta fill in my I's to the table, which I did. And then 4 says solve V at each resistor. Okay? So I'm gonna use my Ohm's law, V equals I times R. I'm gonna solve for my voltage across each resistor. So I times R, 4 times 1 is 4. 4 times 2, 8. And then step 5 says that check that the total V and R are sums. These add up to be 3. 8 plus 4 adds up to be 12. I am correct. Any questions about that? All right, look underneath your warm-up. You got some practice ones. All right, in this case, number 1, I have a 48 volt battery and a 10 ohm resistor. What is my I? How'd you do that? So I is equal to V over R. So I is equal to 4.8 amps.
These are all the exact same. That's what I was gonna ask when you did the thing and I said your name. Because like I did the bottom one, so I was
Okay.
Before we got there.
So the thing is with these is that they are series circuits. So if you had multiple resistors, you'd have to make sure to follow the series steps.
since I don't, and it's fine.
All right, so in this case, it wants for the voltage. So voltage is equal to I times R, which would be 6 times 20, which is 120 volts. Super easy, right? Totally genius. Here it wants the resistor. So R is equal to V over I, which is going to be 20 over 4, which is going to be 5 ohms. Don't forget your units. Okay, here it wants I again. I is equal to V over R. 60 over 30 equals 2 what? Amps. Is there any questions about this so far? All right, let's look at your assignment. Okay, I'm going off of this one. All right, I'm under week 11, Ohm's law. It says build a series circuit. Click there. All right, so it says use the link in the Google Classroom to use an item, click and drag it onto the screen. All right, simple circuit, 1 resistor. Construct a simple circuit that contains the following components: a light bulb, a battery, and a switch. So I need a light bulb, I need a battery, I need a switch. What else am I missing? No, didn't ask for a resistor. Gotta connect everything with wire. So I go from my battery to my light bulb, my switch, to the other side of the battery. And when I close the switch, I have light. Okay, it says use a voltmeter to measure the potential difference of the battery. You would, again, just drag this puppy out. See if I can get I regret my decision placement here. All right. You would drag this puppy like that, 9 volts. Okay. It says record the current flowing through by reading the ammeter, which again, same thing. Like, y'all got this. Is there any questions? Yes, it is on the classroom. If you keep yawning, I'm gonna move you away from me. I did not get my.
Sit right here.